We spend billions building powerful telescopes, hoping to find another Earth. But finding a habitable planet is only half the problem. The universe is incredibly physically immense. We are surrounded by an uncrossable void, meaning any world we discover remains functionally out of reach. Take our closest neighboring galaxy, Andromeda. It sits roughly 2.5 million light-years away from Earth. Even if we engineered a spacecraft capable of traveling at the absolute speed limit of the universe, the speed of light, a one-way trip to Andromeda would still take 2.5 million years. Building a faster engine does not solve this. No amount of linear acceleration allows a human being to survive a multi-million-year transit. If humanity is ever going to leave this galaxy, we have to stop trying to fly in a straight line through space. We have to find a shortcut to cheat the distance entirely. In 1915, Albert Einstein published his field equations of relativity. His work describes space as a flexible mesh that curves and bends when exposed to mass and energy. By 1935, Einstein and his assistant Nathan Rosen found a specific solution within those equations. They realized that applying intense gravity could warp that mesh so severely that it would fold back on itself, bringing two incredibly distant points right next to each other. Physicist John Wheeler later compared this to an apple. If an insect wants to get to the other side, crawling all the way across the outer skin takes time. But if it can burrow through the center, it creates a much shorter path. Instead of crossing millions of light years along the three-dimensional surface, you take a four-dimensional tunnel, instantly bridging the entire gap. Wheeler coined a term for this specific spatial folding mechanism. He called it a wormhole. The math perfectly allows this tunnel to exist. But forcing the fabric of space-time to actually puncture and open requires a staggering physical force. Tearing open the entrance of a wormhole requires an object with enough raw gravitational power to pull the fabric of space downward until it breaks. The universe already builds objects with this level of gravitational power. We call them black holes. Everything nearby gets pulled toward them and into the crushing gravity well below. But using a black hole as a doorway introduces a fatal engineering flaw. A black hole's gravity creates a point of no return. Anything entering is completely trapped. It becomes a dead end rather than a transit system. To make this mechanism survivable, you need a mandatory opposing component on the other side. You need a white hole. A white hole functions as an impenetrable cosmic exit door. Instead of pulling things in, it violently expels matter and light outward, preventing anything from ever returning inside. Connect these three pieces together, and you have a functional transit system. The black hole pulls you in, the wormhole acts as the connecting corridor, and the white hole pushes you safely out. Successfully crossing the universe requires engineering a gravitational vacuum perfectly paired with a cosmic exhaust vent. You might be thinking this is all conjecture. Human passable wormholes and white holes currently exist only as complex mathematics written on chalkboards. But it is worth noting that black holes were also dismissed as impossible mathematical quirks for nearly a century. We knew they existed in the math long before we could see them. It took until 2019 for our technology to catch up and finally capture photographic proof of a black hole. Lab results are already starting to reflect the wormhole math. In 2015, scientists used superconducting materials to engineer a miniature artificial magnetic wormhole. A magnetic field entered one end, completely vanished into an invisible gap, and spontaneously re-emerged from a separated point. Beyond the lab, we are seeing unexplained phenomena in the sky. In 2006, an observatory detected a massive, highly energetic flash of light called a gamma-ray burst. Without a dying star attached to this explosion, astrophysicists theorized we might have caught our very first glimpse of a white hole firing. We are rapidly moving from paper equations to physical lab models and distant cosmic observations. This shortcut is a physical mechanism written into the laws of gravity and space. The blueprint exists. The next step is developing the technology.